Welcome back. Today I will be teaching you how to add and subtract vectors. It's relatively easy to understand and not a complicated process, but I'm going to try to explain it to you in a couple different ways. Visually, we can take the two vectors and place them end to end. Let's take a peek. Hey, that looks a lot like a parallelogram. And guess what? It's called the Parallelogram Law. There's your easy way to remember how to add vectors. Addition is also commutative for vectors, just like numbers, meaning the order doesn't matter as long as any negatives or subtraction signs stay with their vector, so a minus b is the same as negative b plus a. IJK form is the easiest and most accurate way to add vectors, so we will always convert to IJK form before doing any addition or subtraction with vectors, even though you could technically do a very precise drawing of the parallelogram law. The problem with these drawings is they're prone to errors and don't work for 3D, since you can't draw 3D vectors on paper easily, so we won't be using this method. We will, however, be using the equations we derived in the last video, so I hope you were paying attention. I'm just going to flash the equations on screen for a couple seconds so you can find them easily. Basically, once we get the vector into IJK form, we just need to add the I pieces of both vectors to get the I piece of the resultant vector, then add the j pieces to get the j piece of the resultant vector, and finally add the k pieces to get the k piece of the resultant. After that, we're done. We can convert that resultant vector back to magnitude and angles form if we need to, but either way, we have the new vector. Now let's talk about negative or subtracted vectors. To flip the sign of a vector in IJK form, we simply flip the sign of the I, j, and k pieces. The other way to think about this is as distributing a -1 into the IJK form vector. It'll be easiest to show the magnitude and angles form in a negative sense with computer graphics, but the short answer is that the equations from last video will take care of it. Just plug the magnitude in as a negative and it'll work, but to understand this better, let's go to the snake pit. Any vector and its opposite or negative will have the same magnitudes, but they will face opposite directions. Let's look at a 2D example of this. I've placed the two opposite vectors next to each other so you can clearly see which is which. You can see they face opposite directions but are otherwise the same. Now, if we switch to 3D, we can see the same thing, just with an extra dimension to consider. By definition, this means the two opposite vectors add to 0, because if we put them end to end, we will end up back at the start point. There's one more thing I wanted to show you before we end, and that is the parallelogram law in 3D. You can see that even when we add up 3D vectors, a parallelogram is created. That's all I have for today, so thanks for watching. If you found this video helpful, please like and subscribe and tell your classmates. I will also be uploading some practice problems with video answers that can be accessed in the paid statics course at my website, meki.education. See you next time.